All right, year 10s, let's go through this example. So definitely using the cosine rule here for this one. So find the angle theta in this triangle, correct to 2 decimal places. And I can tell that I'm going to be using the cosine rule because I have an angle that I'm asked to find. Now, just because I'm asked to find an angle doesn't necessarily mean I'll use the cosine rule. The evidence that I have to suggest I will be using the cosine rule is that I've been given all 3 sides. And that's a key idea that we learned from our last video, right? If finding an angle, all 3 sides must be known. And that's a condition for using the cosine rule. So let's go ahead and pick this cosine rule up, and I'll actually use it for our working out in this question. All right. Just remember though, I just want you to kind of refresh your mind on this one. All right, for notation with these types of triangle problems, angles are used, angles are represented by capital letters, and their corresponding sides, diagonally opposite is what I mean by corresponding, are always lowercase. Okay, so let's go ahead and just look at the formula real quick. You'll see that the only place that we're inputting an angle is this position here, because that's the capital letter that indicates an angle in a triangle. And so if you think about the question that we've got, we're asked to find theta, which is an angle in this triangle. Here it is here. The only position that we're going to try and make the subject of for this formula is C here. So ultimately, we have to find this part of the formula. We have to make this C the subject of the formula, because ultimately we're trying to find the angle, okay? So with that in mind, we're actually going to go ahead and we're going to let C equal automatically, just to let us know what we're doing. It's good communication. We're going to let it equal theta, because that's the letter or the pronumeral or variable that's been given to us in the question. It's kind of like substituting, but just kind of initially so that we don't get confused with ourselves. So we're letting C equal theta. Now I can go ahead and just start substituting with our formula. It's fairly straightforward. So let's go ahead and do it. So C, this is the lowercase c. Remember, that's always opposite to the angle. And in our case, the angle that we're interested in, theta, well, what's opposite to theta? That side, which is 8. So let's go ahead and write 8 instead of C. We're substituting now. Now the next ones are A and B. Technically, because you are adding the 2 sides together from the question, the 2 remaining sides rather, just because you're adding them, you don't really need to assign A to a particular number or B to a particular number. As long as you are consistent throughout your working out, you just commit to one. So A could be 12 or A could be 13, it doesn't matter. For the purposes of being consistent with the example in the textbook, I'll make A 13. So let's go ahead and write that, 13 squared, and then plus the other side, which will be 12 squared. And now we're going to subtract 2 multiplied by A, which we determined was 13. So let's be consistent, multiplied by 12, multiplied by cos C, which is now theta, as we established here. Okay, so our next step now is just to keep working through. We're going to try and solve as much as we can, and eventually we'll start rearranging to make theta the subject. All right, here we go. 8 squared, 64, equals. Now, 13 squared is 169, plus 144. That gives us 313. Minus 2 times 13 times 12. That'll give us 312. Cos theta. Okay, so we're ultimately trying to find theta. Cos theta, we're also trying to find. That'll be the last step. So we've got these 2 numbers we're trying to get rid of, 313 and negative 312. You'd be right if you were to suggest that we could get rid of 313, and we could do that, but we're left then with a negative. And I think what we could do is, because that negative is attached to our cos theta, what we can do is actually get rid of this first, and you'll see what happens. if we get rid of negative 312 cos theta, if we get rid of it, well, firstly, we'll have to get rid of it by reversing the operation of negative 312 by adding 312 cos theta. And that'll get rid of everything because, well, negative 312 cos theta plus 312 cos theta is 0. But remember, whatever you do to one side, you've got to do to the other side. So see what our result will be. We've removed the negative sign. That's going to make our working out a little bit easier. So let's go ahead and do that. All right. So watch. I'll just make some space here. Sorry, I know you don't have the privilege of doing this, but we'll just go with it. So I'm going to go ahead and add 312 cos theta to both sides. All right, and now this part gets eliminated. And I'm now left with 64 and 312 cos theta equals 313. So now I've got this nice expression here, or term. I want to remove 64. I will do it by subtracting 64 from both sides. All right. Sorry, that should be really staying here. And we are going to subtract 64 from both sides. In doing so, this is eliminated, and now I'm left with 312 cos theta equals 313 take 64. That should be 249. All right, getting close. We'll keep going. I'm trying to isolate cos theta. So if I need to get rid of 312, again, that's multiplying. I will then divide by 312, but I'll have to do it to both sides because whatever you do to the left, you do to the right. All right, that's what I'll do here. So here we go. Divided by, sorry, let's be consistent with the colors. Divided by 312, but we need to do it to both sides. They all cancel out. And what you get is that cos theta equals 249 divided by 312. Now, I wouldn't put that into the, I wouldn't round anything just yet. And here's the reason why. Let's go up here. This is ultimately what you're going to put in the calculator, all right? So let me write that expression again. So we've got a nice base of where we're thinking. So the cosine of theta is 249 divided by 312. But what we're going to do is we're going to try and find theta, all right? So theta, and it's not as if we're dividing by cosine or dividing by cos on both sides, because that's not what this is. It's not cosine times theta. This is the cosine of theta, all right? And the reverse operation is the inverse operation of cosine theta. And the way that we write it, and I'm sure that you can recall this, is that it looks like cosine to the power of -1, but it's the inverse of cosine of that ratio. So 249 over 312. And so hopefully you can realize we don't round here. We try and keep the values as a ratio rather than writing as decimal, because we retain all the value. Okay, so put that into the calculator. You would just press shift and then cos, and then put the ratio in, and hopefully you'll get 37 point, and round to 2 decimal places, 0.5 degrees. And so that's how we do, that's how we use the cosine rule, okay? For this particular example where you've got an included angle, or an angle, and then all 3 sides known. In the next example, well, you'll see the next condition. So I'll make a new video for that one.